Okay, guys, good evening. So we can start the class right now. So yesterday we discussed about the components, network components. Okay, so we discussed a little bit about router, switches, right? Those things. I'll take a slide to display to discuss about those things little later. So we can go from here. So I can do an overview of these networks, right? For this overview. Let me finish this thing. Okay. Yesterday I discussed about the routers, right? I explained what is the use of router, where we use, right? Actually the definition for the router is fundamental job of a router is to make packet forwarding decision based on destination IP address information. Okay, based on IP address informations. Okay, so we must know the destination IP, right? Then only the source can communicate with the destinations. What is source? What is destination? Source means the starting place. That means starter, right? And the destination ending place. So the laptop is going to communicate with the server. That means web server. Okay. So the source is laptop. The destination is web server. That means the packet is going to go from the laptop to the web server. Okay. So the packet is going to forward it, right? The packet is going to be forwarded through this link. This is one local area network. The other one is another local area network, right? So both are different, both are in the different networks. That is obvious. You can see here. This is 192.168.1.0 network. And this is 10.1.1.0 network. So both are in different networks, right? So already I told you to communicate between different networks, we must have a router in between. Okay. So we have router here. The router will forward the packet from this network to the other network. Understand? So we need a source IP address and the destination IP address to forward the packet. Okay, so that I think you know. Yesterday also I explained about the OSI layers, right? OSI model. In that OSI model, there is a layer called network layer is responsible for the IP address. Okay, so there only we assign IP address. So we have to assign source and the destination IP address to create the packet. In this scenario, right? Right. Now, in this scenario, the laptop wants to send a packet to the destination web server. The packet must be having a H4, right? That H3. That means layer 3 header. Layer 3 header is having the details of source IP address and destination IP address. And also it will be having the data, right? Data is encapsulated with this header. This is happening in layer 3. Layer 3. That is called network layer. The network layer protocol data unit is called packet. Okay. Always the packet is having source IP address and the destination IP address of the source and the destination. So the source IP is going to be this IP address. What is the IP address of this laptop? 10.1.1.100. 10.1.1.100. This is the IP address of this laptop. What is the destination IP address? Destination IP address is the IP address of this server. That is 192.168.1.200. Okay. This is the destination IP address. Now the laptop wants to send the packet, right? It has to send the packet. Then it needs source in the destination IP address detail. So can you give me 1 minute? Sorry, guys. Okay. Now the laptop needs the source in the destination IP address. Okay. So it knows, right? It knows this IP address and the destination IP address. We can take IP address from the destination, right? So you can call and ask, or they will provide the destination IP address. Then the laptop can use that. Okay. So the source IP, it is known, and also the destination IP also known. So it can create the packet. It can create the packet. So the packet will be created. Packet will be created. 1 second. We just watch carefully. Okay. The packet will be created. So you can identify how the packet or data is traveling through the network. Now the packet is created. Okay, the packet is already created. Now it has to send the packet. How can it send? How can it send the packet? So to send the packets, it has to create the frame as well. Why? Because there is a layer 2 device here. Layer 2 device always use MAC address. This is using MAC address. Okay. So, but the router using IP address. So the IP address details will be there in the routing table. Okay. This is called routing table. The routing table existing in the router. And also the router is having ARP table. ARP table. Both table is right. Both tables are in this router. And also the laptop is having ARP table. The MAC address is having, sorry, the switch is having MAC address table. So this is the routing table, right? Looks like. Routing table looks like this. Okay, now the packet is created. Again, it has to create the frame, right? If the laptop wants to create the frame, it needs another header details. Okay, these are the details they need. What data is here? This is trailer. Okay, this is H3. Then it needs H4. Sorry, H2. Layer 2 header. With this data, there is another header. It is called H4, right? That is TCP header. H4. H4 is here. Inside this, H4 is there. Right? H4 is having the details of port details, right? That is source port and the destination port details. Now the laptop needs source MAC address and the destination MAC address details. Okay. Source MAC address, it is well known. Why? Because it is its MAC address, right? The laptop's MAC address, it is locally available. So source MAC address is available. And how about the destination MAC address? Destination MAC address, we don't know, right? First, before finding this destination MAC address, it has to find where it, now the moment destination MAC address is not available. Why? The destination is in the next network. Okay. Now it will identify according to the IP address, right? Source and the destination. It will examine the destination IP address now. And it will come to the conclusion that it has to send the packet to the default gateway. Default gateway. Why? Because the both addresses are in different networks. That means source and the destination. So destination is in the different networks in the sense it has to send the packet to the default gateway. Okay. It has to send the packet to the default gateway. So beyond that, it cannot send, right? So first of all, it has to find the MAC address of this default gateway. Why? Because in this network, it can communicate, the laptop can communicate within the network only. So it can reach up to this default gateway interface. Beyond that, it cannot. Why? Because the router wants to examine or test the destination network. It has to find the destination network and the exiting interface. Now it will check the routing table will be having the details of interface and the network, which network is connected to which interface. Okay. So now this gig3 interface is connected to this network. Gig1 interface is connected to this network. Understand? Now, if laptop wants to send this frame, listen carefully. If laptop wants to send this frame, this is frame, it needs source and the MAC address, source and the destination MAC address. The source MAC address is available, but destination MAC address is not available. What will do? It will send a ARP message to find this MAC address, to find this interface MAC address. So the ARP message will be going to this the default gateway interface, and then it will check the IP address of this interface. And if the IP address is match with this destination MAC address, with this destination IP address, then it will forward the MAC address to the laptop. Okay. How the ARP is done? ARP also sending a message with the details of MAC address, that means source MAC, destination MAC address, source IP, destination IP. Okay. These details will be there in the ARP table, right? Now it will say, I am having this MAC address. I am having this IP address. Are there anybody with this IP address? It will ask. Destination, right? It will ask, are there anybody with this IP address? So this IP address already we configured with this laptop, right? That means default gateway IP. I will show you, right? Default gateway IP. It may be, what is this IP? 10.1.1.1. So 10.1.1.1. This is the default gateway IP. Now it will reach the ARP message will reach this interface, and it will check for the IP address. Okay. Then now IP address is matching. Then what will it do? It will say the router interface, I am the 10.1.1.1. So my MAC address is this, maybe AAA. Okay. So it will send it to the laptop as a reply message. So the request is happening here. That is ARP request. This is request. This is reply is sent by this interface, router interface, or sent by router. Now the laptop will come to know the destination MAC address. Understand? Now it will come to know the destination MAC address. So now everything is available. Source MAC address available, destination MAC address available. So destination means the default gateway only, not these destinations. The IP will not change. Now the MAC is going to change. It will send the packet or frame from laptop to default gateway. Again, this interface to the destination. Here we are using MAC address. Inside the router, we are checking with the IP address. This is what happening here in this data transfer. So this is the function of the router. What is the function of the router? Function of the router is to send the message from one network to another network. It's like a translator, or translator, right? It's like a translator. Okay, guys. So the routers, the fundamental job of a router is to make packet forwarding decision based on destination IP address information. Okay. And here in router, there will be a routing table. It's having the details of interface and the particular, that means associated network. This gig 1 is associated with 0.0.0.0. Gig 2 is associated with 10.1.1.0. Gig 3 is associated with 192.168.1.0 network. Okay, this is router. Now then we can move on to the next device, that is the switch. Ethernet switch is going to make a frame forwarding decision based on destination MAC address information. In MAC switches, you can see a MAC address table here. So the port, which port is associated with which MAC address? This port is associated with this MAC address. So MAC address mean the device MAC address. Okay, the device which is connected to that particular port. So switch will learn the MAC address of this device, this device. So all device MAC address will be learned by this switch, and it will be stored in the MAC address table. Okay. So the main function of the switch is Ethernet switch is going to make frame forwarding decision. Here it is taking the frame forwarding decision. In router, it is packet forwarding decision. Okay. The frame forwarding decision based on destination MAC address information. Destination MAC address information. Security appliance, that is intrusion prevention system, IPS sensor. What is the use of this sensor? It always match the threads with the database. If it is matching, then it will drop the packet. It's having the details of the threads in its database. An appliance that sits in line with traffic and checks that traffic against the database of known threads. All known threads are stored in the database. It will check if there is any threads comes. If a thread is detected, the offending packet can be dropped. So it will drop. It is done by IPS, intrusion prevention system. Next security appliance. It is firewall, right? It is well known name, firewall. Next generation firewall, that is NGFW. It's also called layer 7 firewall. Okay, what are the features available? An application layer firewall with additional features such as deep packet inspection, DPI, right? It can prevent the URLs and also the keywords. We can block by using the keyword. Such facilities available in DPI. Intrusion prevention system, just before we discussed, and encrypted traffic inspection. All these facilities are available in NGFW, next generation firewall. It's a firewall. These are simple. It is ad hoc wireless LAN. This is infrastructure wireless LAN. This is mesh wireless LAN. Everything, these things will be discussed in wireless sections. It's a separate sections we have to discuss. So that's why I'm just passing this. This is enterprise wireless LAN. Okay, it looks like this. AP is there, access point is there, switch is there, and also WLC, wireless LAN controller, also will be there to control these APs. The next, endpoints and servers. Endpoints, servers, right? Endpoints mean PCs, okay, or printer, or storage device, anything. This may be server, right? It is given server separately. Endpoints mean the end user devices, also known as client server architecture. Here will be a server. The server will control all the clients. That type of network is called client server network. Okay, so here for an example, I can say in server 2012, if you are installing is 2012, and at that time we have to install the Active Directory as well. What is the purpose of using Active Directory? AD always maintain or manage the clients. So another type of architecture is there, that is peer-to-peer architecture. All are act as clients. So all can share the resources. Clients share resources. Not as robust as using a network operating system. This is simple. It is called peer-to-peer architecture. Peer-to-peer architecture. It's like a work group. The next one, this one can also manage the network. What is this? This is called Cisco DNA Center. DNA Center is there is an appliance, physical appliance. Cisco DNA Center is an appliance that means device that provides a graphical interface and a programming interface to design your network. So by using this appliance, we can design our network, right? We can deploy, we can add, and we can configure devices. We can add we can monitor and troubleshoot your networks. All these functions can be done by using this Cisco DNA Center. So later I will discuss about this. For the timing, I'm just explaining about DNA. And what are the facilities available in this DNA Center? So we can design the network, we can impose or we can implement the policies, we can provisions, we can deploy, we can provision mean we can add the devices, we can manage, we can assurance, right? The assurance mean we can check the health condition of this network devices and also platform. So these are the features available in DNA Center. We can do everything by using this DNA, right? We can design, we can assign policies, we can we can deploy, we can add the devices, right? And also we can manage, we can find the health condition of the network. So this is called ACI, Application Centric Infrastructure, right? Next. This is virtual server. You know what is virtual servers? Virtual server can be installed in VirtualBox or VMware. It's a kind of hypervision. We can create, we can start, we can stop, and we can monitor multiple virtual machines in hypervision. Right? What are those hypervisors? VirtualBox is a hypervisor. VMware is there. Hyper-V is there. That is the product of Microsoft. Those are the hypervisors. So we can create machines, we can manage. There are two types. One type is called, it is metal, bare metal, or native. That means in that type of machine, a hypervisor, we are not going to install operating system. Directly we install what? The components. That means it may be Linux server, Microsoft Windows server, Oracle Solaris servers. So this can be directly installed onto this hypervisor. That type of installation is called native or bare metal. Type 1. The type 2 is there's a computer. In computer, there may be operating system, right? There will be more operating systems. On top of that operating system, we can install another operating system. That is called the second type, type 2, hosted. Runs in a traditional operating system. Right? In first type, your machine is there. You are installing directly what? Windows Server, something like that. Windows Server. Windows Server. Direct. But in type 2, machine is there. First you install Windows 10. And then top of this Windows 10, you are installing other operating systems. It may be Linux or Windows, another Windows 10 machine or Windows Server. So everything can be created on top of this Windows 10. So now that Windows 10 is host, these machines are virtual machines are guests. So those are called type 1 and type 2. Next. Right? The virtualization, the virtual NIC, virtual switch is there. So virtual NIC 1, virtual NIC 2. So it depends on the number of devices being installed. Don't worry about these things will be discussed in later section. Okay. So now I am doing virtual services. Here the cloud providers router. This is cloud, right? Cloud provider. The virtual firewall is there, virtual router is there, cloud providers, virtual lab, right? SLB, right? The enterprise can access through the cloud. These are called virtual services. So which will be taken from the cloud providers. What is TCP versus UDP? The TCP, transmission control protocol, always do synchronization. Synchronization and acknowledgement. This is called three-way handshake. Three-way handshake. This is the mechanism of three-way handshakes. First, it will send synchronizing packet, and sequence is equal to X, and send sequence, and again acknowledgement 1. So pack X plus 1. So it will ask for the next pack, and it will synchronize, right? So this operation I can discuss later. Right. Now you can see bidirectional communication. Bidirectional communication means the two-way communication, right? Source IP 10.1.1 is a source port. Destination IP is 172.16.1.2. So both are in different networks, right? Both are in different network. The destination port is 80, source port is 49,158. Now you see source IP address is 1.2. That means the server is sending the reply, and source port is 80, destination is 10.1.1, destination port is 49,158. So this is bidirectional communications. Both are communicating each other. Okay. Right. Now you will come to know well-known port. The port number in the range 0 to 1023, which is used by a system-wide service. Okay. That is well-known port. Well-known port means 80 is a well-known. So that means 0 to 1023. Right? Next. Next port is registered port. It is coming between 10,024 and 49,151. Okay. 49,151, which is used to communicate with a specific application. Specific application. So these ports are called registered port, but this is not registered port, right? 49,158. 49,158. Okay. Next. The last one is dynamic or private port. So this one belongs to private port, 49,150. You can see it is starting from 49,152 and 65,535. Why it's not going down? You can see 49,152, 65,535, which is selected by a network device to receive return traffic. So this type of port is called dynamic or private port. So already we discussed about three ports. The first one is called well-known port. Okay, well-known port. And second one registered port. Third one dynamic or private port. You can see some of protocol and the particular related port, TCP port or UDP port. FTP always use 20 and 21, SSH 22, SFTP 22, and Telnet 23, SMTP 25, like that, right? DNS 53, both, it is using both, right? UDP and TCP. Likewise, the HTTP is using 80 and HTTPS using 444, right? Likewise, it varies from 0 to 1023. Next, we'll discuss about the architecture a little bit. Okay. Leave it here. Right. This is called collapse core or three-tier architecture, right? Collapse core versus three-tier. So this is collapse core. Collapse core means combining core and the distribution layers. You can see here the previous one. Core is there, distribution is there, access or layers also there. So there are three layers. That's why we call three-tier architecture. A partial mesh topology, a hybrid topology. Okay. Next. So this is collapse core layer. This is access layer. There are two layers. Another layer is there. That is spine leaf designed for data centers. So this is specially designed for data centers. These switches are called spine switches. These switches are called leaf switches. So each and every leaf switch is connected to the spine switches. So actually this is logically one switch, a spine switch. The next, wide area network, WAN topology. What are the technologies we are using to connect wide area network? traditionally slower speed than LANs, that is well known, and geographically dispersed sites. Sites connect to service provider. Okay? Sites connect to service provider. Wide area network topologies. Examples of WAN connectivity: point to point, point to multi-point, internet with VPN, MPLS, Metro, Ethernet. These are the technologies of WAN. Point to point, it is directly connected. Point to multi-point mean it will be connected to different routers. From one router to different routers. Okay, next. You can see point to point. What is point to point? Interconnects two devices, only two devices. Typically uses a layer 2 protocol. Here, point to point is always used layer 2 protocol. From here to send traffic from here to here, it need MAC address table. This is HTLC, high level data link control, Cisco's default layer 2 encapsulation on serial ports. Next, point to point. This is point to multiple. This is point to multiple. This is normally we do in frame relay network. Layer 2 protocol that interconnected sites using virtual circuits, VCs. These VCs were known by numbers called data link connection identifier, DLC. The next one, internet with VPN, right? It is the direct connection, right? There are several VPNs available. This is site-to-site VPN, site-to-site VPN, right? That provides privacy over the public internet. So it is connected to internet, but it is a little bit privacy, maintaining privacy. That means the R1 can communicate with R2 without interacting anybody outside. So no one can see the data. It will encapsulate it. Okay, this is low cost, widely available. The next one is MPLS, multi-protocol label switch. Right? Multi-protocol label switching done between this service provider network. This is CE customer edge. This is PE provider edge. This is LSR. This is PE provider edge. This is customer edge. So in between, we are doing multi-protocol label switching. This is label switching routers, LSR. Metropolitan area network, MAN, June. So these are the MAN connections, right? Limited availability, very high speed, redundant. It's redundant. The next one, metropolitan area network, each wavelength is called a lambda. What it is? Right. Now we can move on to the copper cable. If you want to connect the network devices, you have to consider about the cables, right? So there are two types of cables available nowadays. One is UTP cable, the other one is fiber cable. UTP and fiber. Right. Let me explain about the copper cable first. So there are cables, type of cables coming under copper cable, unshielded twisted pair UTP, shielded twisted pair STP, plenum braided. And these two are very famous, right? Twisted pair cables. This is coaxial cable. Coaxial cables nowadays we are not using to connect network devices. Electromagnetic interference (EMI) occurs when radio waves are picked up by or radiated by a cable carrying another signal, resulting in signal degradation. Impedance, a circuit's opposition to traffic flow measured in ohms. Don't worry about that. The categories of twisted pair cables. The category 3, 5, 5E, 6, 6A, and 7. Nowadays, we are using 10 gig base T and pods. Cat3, 1000 base T. So actually, all the categories can transmit the signal up to 100 meters. Okay. The straight through or versus crossover case. So how we can do this type of cabling? You know, actually in color code, there's a color coding system that is T568B and A. So normally I do 568B cabling types. So there are 8 pins, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the straight through versus crossover cables actually cable in different manners. Let me show you. What is a straight through? Straight through cabling means we are connecting both end of the cable in the same order, color coding order. What is the color coding? White, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So this is the color coding order, right? We can match next and as well. So we have to do the cabling, or we have to crimp according to the color coding. Right. So today we can finish with this topic, like cabling. So straight through, cross cable, crossover, product. Okay. These are the three types of cable. So the straight through cable always done 1 to 1, 2 to 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 8. So both sides is going to be in the same order. In cross cable, one side will be the order 8, and it has to be crossed 1 to 3, 2 to 6, and 3 to 1, 4 to 4, 5 to 5, 6 to 2, 7 to 7, 8 to 8. Right? In this manner, we have to cross. Cross mean 1 always connected to 3, 2 goes to 6, 3 goes to 1, like that. What is rollover cable? Rollover cable also, the one side will be the same order 1, 2, 3, 4, 5, 6, 7, 8. Here, the rollover means the upside down, that is 8, 7, 6. So the color coding is going to be white, orange, orange, white, green, blue, white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So this is the standard color code, that is 5, 6, 8. Okay. Another question, why we are doing these three type of cable? Rollover is used to connect especially router or switch with the PC for the purpose of configuration. Okay. The next, the straight through always used to connect different types of devices. Different types. Crossover always use same type of devices. Okay, 2 to 6. The crossover always connect same type of device. Same type of devices. That means we can categorize the devices into two. Okay, layer 2 and layer 3. Under layer 2, we can categorize switch and hub. Okay, switch, hub, same type. About layer 3, router, router and PC. So these two are same layer. These two are same layer. Switch and hub. Right, for this purpose only we are doing crossing cable. Right. Right. If you are connecting router with the router, then you have to use straight through cable. Sorry, crossover cable. Or PC to PC cross cable. Okay. Now, if you are connecting router to router, what is the cable you have to use? Same type of device. Okay,
Sir,
same type. Oh, yeah.
what is the use of rollover cable, sir?
Rollover cable is used to connect router or switch, router or switch with the laptop or desktop for the purpose of configurations. Here, actually rollover cable means it is console cable. Okay, understand? Console cable.
Oh,
Yesterday I
okay,
showed
sir.
you. Yeah.
Yes.
Crossover cable we are using to connect the same type of devices. That means switch to switch, switch to switch. So we use what crossover. If you are connecting a router with the switch, then it is different device. We can use it straight. Understand? I think you can understand. Yes, I will provide. So for the timing, I am unable to provide the uh, workbook and the study guide. Why? Because the non-paid students also they are in the group. So after segregating, so I will send you the PDF. Okay, so both PDF, workbook and the study guide. Okay, right. So actually, I am planning to stop here because I am planning, as I told you, I'm planning to run the advertisement one more week. So next week also we can get some students. So because three are paid already, Abe and Kesavan, and also one more person paid. He's absent today. Anyway, we'll provide the recording. So altogether three students. In the last batch, I had almost 20 students. Okay, so now we got only three. So I'm going to advertise one more week, so we can get some more students. Okay. So the next week also will be repeated. The same thing, and also the updated versions will be done. Okay. So sorry for that. Then anyway, it's going to repeat you guys as well, right? So okay.
Okay, sir.
Anyway, I am going to wind up. So before that, I show you in last class. You see, mm, the last batch, Saturday, Sunday, Saturday and Sunday batch two. This is the last batch, the previous batch. That means the finally I got. You see here, 23 students are there. Almost 21. So 22 something. 22 or more than 20. So we'll see. Okay. So so we can do the class perfectly. Don't worry. So I will do. So today I didn't touch the practical. So from next week onwards, It's going to be per. Okay. So from next week onward, we can do properly the classes with practical and everything. Right. I will use uh, different slides and I will explain myself. Right. So you can get more knowledge. And also I will use uh, questions. I will discuss questions finally. Before that, we'll finish all the theories and practicals. Okay. So once this is finished, then you can go for the exam. No need to worry. Okay,
Okay,
guys.
sir.
Okay, I'm going to end up. Okay, thank you. I'm going to stop.
Okay, thank you, sir.
Thank
Good
you very
night.
much. Good night. Bye.